We're working on finding the inverse of a particular matrix. Now, we're going to be dealing specifically in this video with a 2 by 2 matrix. There is a formula that we use in order to find the inverse of a 2 by 2 matrix. And that formula is right here. And this is a big, long formula that looks fairly complicated. We've got an A, B, C, a D. In fact, we've got two A's. We've got a capital A, and then we've got a lowercase a. Capital letters usually denote a matrix of any kind. And then these are just unknowns at this point, okay? And then that equals, the inverse here, which is A. Remember these negative ones, we've used these inverse notations before, A to the negative 1. That's the inverse of this, equals, and then here's our formula that we're going to use for it. But it sounds fairly complicated, so let's look at an example here in which we will actually have real numbers instead of just letters. So here's our example. This is a 2 by 2 matrix. On the top row we've got 4 and 5, and on the bottom row we've got a 2 and a 3. Okay, then if we're trying to take our inverse of this one, the inverse here says A times D. So right here we go diagonal. We're going to multiply these two together. 1 over this, excuse me. So let's do that now. So now here's our inverse. Again, we denote that with our negative 1 here. So we're going to multiply this A times D, this 4 times 3. So this is going to be 1 over 4 times 3 minus B times C. So again, we're going to multiply this diagonal here again. Right here, so let's see, B is 5 and C is 2. So this is going to be 4 times this diagonal minus this diagonal. Okay, let's see, so we're going to multiply these two 5 times 2. All right, now, then we get this new times this matrix right here. And this one, you notice all of these kind of seem to move around a little bit. They changed in one fashion or another. So let's take our original matrix that we've got here. I'm just going to rewrite it down here just for illustration purposes only. Now, what it's telling us here is this A and D, if you notice here, these two switched spots. The A was in the upper left, now it's going to be in the bottom right. The D was in the bottom right, now it's going to be in the upper left. So essentially what we're doing here is we're taking these two numbers and we're switching them. Okay, whatever these two numbers were, we're just going to switch them exactly as they appeared first. Now we're just switching their location. And that's going to go right here. Okay, so this is 1 over A times D minus B times C times this new matrix, and the new matrix is going to have these two numbers flipped. Okay, again, this is my original one that I got from here. I just moved it down here just to make it a little bit easier to illustrate what we're doing here. But basically, we just switch these two numbers here in the diagonal. The next thing, notice our B and our C stay where they're at. They didn't change on us at all. But their sign did change. So what we're basically going to do is we're going to change the sign of both these two. Not the location. These two will stay put. However, the sign that's on them will change. So instead of it being a positive 2, it will be a negative 2. And instead of being at a positive 5, it will be a negative 5. Now, if this number were already negative, let's say this were a negative 2, then we'd change the sign and make it a positive 2. Okay, but in this case, these are both positive to begin with, so we're going to change them to a negative sign. Okay, so now I'm going to get rid of this area here only because it doesn't really apply to what we're doing anymore. But that's where our numbers here came from. It's a modification, if you will, from our original matrix here. Okay, so we've got those. Now we just need to simplify what's left here. Well, I'm not going to really worry about this matrix just yet because I've got to simplify this. I've got a lot going on here that I need to make it a little bit easier to understand. I need to know, let's see, 4 times 3 is 12, minus 2 times 5 is 10. So I'm going to have a 12 minus 10. So this is the simplification here. I didn't change anything in this matrix. And we know 12 minus 10 is 2. So now essentially I have the inverse of A is 1/2 times this new matrix here. So now what I'm going to do is take these one at a time. I'm going to multiply each one of these components by 1/2. So 1/2 times 3 is going to be 3/2. And now this is found in the upper left-hand corner, so I'm going to write that in the upper left-hand corner. These are our multiplication of matrices by a scalar factor. It sounds complicated, but basically all we're doing is we're taking this 1/2 and distributing it to each one of these inside of here. So then we go 1/2 times negative 5. Let's see, 1/2 times negative 5 would be negative 5/2. Now you can write this as a decimal if you choose. That's not going to be a problem. You can write them as a fraction too. There's nothing wrong with that. 1/2 times negative 2, that's going to give us negative 1. And 1/2 times 4, that's 4/2, which is just 2. So this would be my answer here. So the inverse of this matrix is this matrix right here. Okay, and we can find that using this formula, and you're going to have to take it one step at a time. And just go through each one of them. You get lots of practice. And the more practice you get, I think it will become clearer to you.